Thanks for joining us today. I'm Jim Lattis, Director of UW Space Place, the Outreach and Education Center of the University of Wisconsin-Madison Department of Astronomy. Today we're going to take a little tour of the winter sky that we have these February evenings and see what some of the sights there can tell us about the evolution of stars. I'll be using Stellarium, and if you've heard any of other star talks from Space Place, you'll know that we use Stellarium quite a bit, and I highly recommend it. It's free and you can download it and install it, and it will do quite a lot for you in terms of both learning about astronomy, but also helping you out as a tool for the hobby of astronomy. So we're going to start by looking at the sky. We've got it here set for early February at about 8 p.m. Around 8 p.m. you'll see that the bright star Capella, which Stellarium is conveniently labeling for us here. Capella is very high overhead, nearly on the meridian. Right around 8 o'clock it'll be right on the meridian, meaning it would be due south, but it's very high in the sky. This particular view in Stellarium, I've zoomed out a good bit, so you're seeing a lot of sky there. That's very, very high overhead there. But I did that for a reason, because we want to look at these winter stars and constellations. The bright stars will guide us around to a number of constellations. Stellarium, of course, is labeling a few of the bright stars. It'll label some and not others. And down here you see two particularly bright stars labeled there, Betelgeuse and Rigel, and you probably know those are in the constellation Orion, which we often notice more easily by those three stars in a row there, the so-called belt stars of Orion. And the belt will direct your gaze over it in a couple of other directions. For example, off to the roughly westward, it points off sort of towards Aldebaran over here, which is in the constellation of Taurus. And if you kind of look off in the other direction from the belt points over this way, sort of to the east roughly, then it points over here at Sirius, the brightest star in the night sky, in the constellation of Canis Major. Of course, if you like, in Stellarium you can do things like turn on the constellation lines that show you the bright stars that go together to make up, in this case, Orion. But we don't need those right now. I'm going to leave those off. If we start over here with Rigel in Orion and swing over to Sirius, we can start making a circuit around the sky here, which is called a lot of different things. I call it the winter oval. People call it various sorts of shapes that will complete a circuit of bright stars from Rigel to Sirius, Canis Major, Procyon in Canis Minor, and then to Pollux and Castor, which Stellarium is not labeling at the moment, then up to Capella, and then back down to Aldebaran, which we just found, and then complete the circuit there, the oval or whatever it is, football maybe, back here at Rigel. So this is a circle, a flattened circle, an oval of stars that you can find in the night sky quite easily. And it's a good way to learn a few of these constellations if you just learn the stars that lead you around the oval. Betelgeuse in Orion is sitting out here surrounded by these other stars. If we turn on the constellation lines and labels now to see what we were looking at, then once again I mentioned Sirius was in Canis Major. Procyon is in the very small constellation of Canis Minor. These are the two dog constellations, the larger one and the smaller one. Canis, of course, means dog in Latin, and the larger dog and the smaller dog. Then we have Gemini, the twins, up here, the constellation Gemini. And then Capella is in the constellation Auriga, right up here. Auriga is the charioteer. Now that's one that not a lot of people know. It's not part of the zodiac, but it does have one of the brightest stars in the sky in it, Capella here. Then back down to Taurus, which of course is the bull and part of the zodiac, and so well known, as is Gemini, another zodiacal constellation. And then back down to Rigel. Here you have the nicest grouping of bright stars that you'll find anywhere in our sky. This relatively close concentration of extremely bright stars. This is a feature of the winter sky that's worth going out and noticing. Any winter, of course, you'll find Betelgeuse and Aldebaran, but this winter Mars is in the neighborhood over here, and so if you look, you'll see this very nice grouping of three kind of reddish objects: Mars, a red planet, Aldebaran, a reddish star, and Betelgeuse, a red giant star as well. So that's a nice sight for this winter. Mars will have moved on by next winter, but we'll still have Aldebaran and Betelgeuse. Another thing to look for is the Milky Way. Now this depends a lot on the conditions, the viewing conditions, wherever you're looking at the sky. But one nice reason to learn this winter oval shape is because the winter Milky Way crosses right through it. Now that's relatively easy to see here on Stellarium. You can see the band of the Milky Way crossing real roughly from Sirius across to Capella that way. If you're in a darker sky, if I turn off the atmospheric effects here so that we see lots more stars, then the Milky Way stands out in much more contrast, and especially down here on the horizon where Stellarium has eliminated the atmospheric effects right now, so that we actually see that the Milky Way is getting brighter and more distinct as we look closer to the horizon. But the atmospheric effect, looking through the atmosphere, has the opposite effect. We don't see it as well down here. We see it better up here overhead. Well, so we went from Betelgeuse and Aldebaran over to Mars, but if we had kept on going a little bit past Aldebaran, not quite as far as Mars, and a little higher, we come to a fairly well-known grouping of stars. Most people know this as the Seven Sisters, although occasionally people know its proper name. It's called the Pleiades. This is a wonderful sight in the sky, and it's great to look at with, say, binoculars, for example. Let's take a look at a photograph so that we can see it in a little bit better contrast. Here we can go to a nice photograph that I swiped off the astronomy picture of the day, which is something that you ought to discover if you're interested in astronomy. Take a look at the astronomy picture of the day, NASA astronomy picture of the day, apod.nasa.gov. So here are three nice objects in the night sky in front of an intriguing carved stone structure. This is Mars down here, and this is the Pleiades. So this is roughly that arc of sky we were looking at over here, and Aldebaran would be a little bit over here. And the other thing that your eye will pick out quickly is the Andromeda Galaxy. There it is, showing up nicely in this photograph. Now that's actually off towards the north in the view that we were looking at in Stellarium, but they make a beautiful pairing up here. And in particular, look at the Pleiades. I said Seven Sisters, but if you look at it there, you'll see that it actually looks a little more complicated than that, and we're going to talk more about that. But there's actually quite a few stars there. So if we zoom in a little bit on this to another slide, here's a much closer slide of the Pleiades in a beautiful photograph. The Seven Sisters, well, some people see 6, but it just depends on how good your eyes are. Some only see 5. But you can see now there are actually lots of stars here in the in the Pleiades. And you can also see what you can't see really at all with the eye is there's a lot of this nebulosity, which the photograph brings out, but you won't see that with the eye, or even with your binoculars, you won't see that. The Pleiades is what astronomers call an open cluster, or they're also called galactic cluster, this category of objects. They tend to be relatively tight groupings of stars. There's a relatively compact group of stars there. These stars are stars that all formed together at about the same time. And we're not talking about just the brightest ones here, but all of them. There are actually hundreds of them here. These stars, the brightest ones there, are among some of the most luminous stars in the sky, hundreds or thousands of times brighter than the sun. There are plenty of stars in here, the vast majority of them, which are much dimmer than that, stars comparable to the brightness of the sun. If you put the sun out in the Pleiades, so that we could see it in comparison with these other stars, it wouldn't jump out at you at all. It would just be one of these kind of much dimmer, ordinary stars there. So the cluster gives us a wide range of stars, from the very brightest, most massive stars to much dimmer stars, things that aren't even really detectable even in big telescopes, very dim stars. We see only these brightest ones by eye. If we did put the sun out there in the Pleiades, we'd be moving it out to about 400 light years. That's about how far the Pleiades is, about 400 light years away from our location, from the Earth and the solar system. Well, let's look now we'll back out a little bit to another lovely photograph that I also swiped from the astronomy picture of the day. Here are the Pleiades. You can see them. Their bright blueness, that blue nebulosity, it makes them jump out here. But now we're seeing them in context of a lot more stuff, a lot more dusty, dark stuff out here. This is the Taurus molecular cloud. What we see out here, these very, very dense regions which are opaque. You can see we can't see any stars. They're blocking our view of this background carpeting of stars in the Milky Way. These molecular clouds are so dense here that we can't see through them in optical light anyway, which is what we get to look at. So this region is much more complex than you would see just with the eye or just with binoculars. The photography brings out all these things that we can't actually perceive directly. One of the things, though, that we can see is another open cluster. It's a little harder to pick out. So there's the Pleiades there, but it's right down here. Here's the other open cluster. And this is the bright star Aldebaran, which we've looked at several times now. This open cluster is easily distinguishable by eye as sort of a V-shaped group of stars like this, which is commonly identified with the head of Taurus the bull. This is actually rather too big to look at even with binoculars. Unless you have extremely wide field binoculars, you won't be able to take in all of these stars at once. But once again, like with the Pleiades, there are many more stars there in the cluster than at first strike us with just the brightest ones. We're seeing just the brightest ones there. The very brightest one there, Aldebaran, though, Aldebaran is not a member of the Hyades. This, if you can imagine this cluster of stars here, try to sort of filter out some of this distracting background stuff here, the molecular cloud stuff. This open cluster right here is the Hyades, is about 150 light years away from us, so a good bit closer than the Pleiades, which are at 400 light years. But what's the distance to Aldebaran? Well, if it's a member of the cluster, it ought to be about the same, but it's actually only about 65 light years. So Aldebaran here is sort of photobombing the Hyades. It's in the foreground of the cluster, which is in general quite a bit further away, roughly double the distance of Aldebaran itself, the bright red star there. So it's not part of the Hyades. Notice a couple of things, though. So the Hyades are, if we just kind of sketch kind of roughly the stars of that cluster, it's quite a bit bigger than the Pleiades, just in terms of its size on the sky. And I mentioned that the Hyades is about 150 light years away, and the Pleiades about 400 light years away. But notice that the stars of the Hyades are actually not tremendously brighter than the stars of the Pleiades, are they? If anything, you might call them real roughly comparable. We're not doing precise photometry here, but that's suspicious that this closer, larger cluster here contains stars that don't seem any much brighter than the stars of the Pleiades. If we brought the Pleiades into 150 light years, so they were at the same distance as the Hyades, they would be tremendously brighter and outshine the Hyades quite a lot. So what does that mean? Well, it means that the Hyades doesn't have as many bright stars as the Pleiades has. In other words, the Hyades is deficient in extremely bright stars. So even though they're both open clusters, there's something really different about them, and that difference turns out to be their age. If we would make a plot of the brightness, the luminosity, we should really say the intrinsic brightness, the luminosity of a population of stars compared with the color of the stars, we would get what astronomers call a color magnitude diagram. So for example, if we could see if we measure the colors, what we usually do is measure the spectra of the individual stars in the Pleiades and plot them along with the magnitudes, with the brightnesses of the stars, we get something called a color magnitude diagram. And sort of generically speaking, what you find when you do this, and this was done by astronomers in the early part of the 20th century, what you find is that there's a general trend among stars, and that among most stars, and that in general, the bluer, which means hotter, stars are much brighter. So this is brightness this way, and blue to red this way. The blue to red turns into temperature. Really, the colors really tell you about the temperatures, the surface temperatures of the stars. So these ones that are bluer and hotter are much brighter than the ones that are more white, more balanced in their color, of intermediate temperatures, and those stars are quite a bit brighter than the ones that are reddish, that are cooler on their surfaces. So there's a general trend of stars. This is called by astronomers the main sequence. It turns out that these much brighter, much hotter stars are systematically more massive. So the main sequence is also a plot, and in effect the temperature and the mass and the brightness all run together. They're all functions of each other. And so these much more hot, bright stars are also much more massive stars, and the much dimmer, cooler stars are much less massive. And the sun falls sort of in here roughly. It's roughly a G type as they're given here. We don't need to go into the spectral classifications. So this is the majority of stars kind of on the average in the galaxy, or if you look around. There are minority populations of stars that pop up, though. There are some stars that are both reddish but also quite bright, and these are the giants and supergiant stars, which end up in sort of the upper right corner of this color magnitude diagram, which you may also know by its other name, the Hertzsprung-Russell diagram. It's been called for many years as well, after the astronomers who sort of worked this out. And then there's another population of stars in the lower left. These are very hot because they're to the left, but very dim because they're low on the chart. These are white dwarf stars down here. So the main sequence stars, if we plotted the stars of, say, the Pleiades, we would find that they lie along a main sequence. what we're coming to here is if we plot the main sequence of a couple of different clusters, or more than a couple, then we find some interesting things going on. So for example, this looks kind of complicated. It's actually several main sequence plots all overlaid on one another, and in general the main sequence runs this way. Once again, this is red towards this way and blue towards this way, and this is brighter as we go up. So here we have a main sequence. This is a main sequence of a particular open cluster identified this way, NGC 2362. If we look down in here, we can find the main sequence of the Pleiades. The Pleiades stars fall along a main sequence, but this main sequence of the Pleiades doesn't extend quite so far up as these other clusters up here do. It has fewer bright stars in it. What about the Hyades? Well, you have to dig in here to find them, but here are the Hyades stars plotted this way. They too lie along the main sequence, but only up to a point. And notice that the Hyades runs out of stars to plot much lower here than the Pleiades. So that makes sense. There are brighter stars here that we can find in the Pleiades than we can find here in the Hyades. You also will notice that some of these clusters, the main sequence is starting to bend. It's starting to diverge from the longer main sequence there. Astronomers call this a turn-off point. It turns out this is telling us about the age of the clusters, because these hot massive stars, if we look up here in this other color magnitude diagram, these most massive stars, they evolve very fast. They burn up their fuel and they do various things. They turn into supergiants, and then supergiants explode as supernovas, and then you don't see them at all anymore. Or less massive stars end up as white dwarfs. But they age off of here, and the ones that age faster are the more massive ones. So if we start off looking at an open cluster and watch it for hundreds of millions of years, we'll see its main sequence kind of burn down as these, like a fuse burning along here, as these much more massive stars age off of the main sequence. At a certain point, they're beginning to move off the main sequence, and it's more complicated than that, but they're no longer up here on this branch in the upper left, and the main sequence is shortened because they've turned off. So the relative length of the main sequence stars, will show us the relative age. So here we have the Pleiades. They're younger than the Hyades, but they're not. But they're older than, for example, these open clusters up here. You can find this one in your binoculars up in the constellation Perseus, by the way. So comparing the color magnitude diagrams reveals the relative ages of the star clusters. Well, let's go back to Stellarium, because now there's something else waiting for us up there. Here we are. There's the Pleiades up there, and there are the Hyades. Let's zoom in a little bit now on this portion of the sky that we've just been talking about here. The Pleiades there, and there are the Hyades, the sort of V shape, and remember that you kind of mentally exclude Aldebaran there from membership in the Hyades. And then come back over here to Orion, because here's where we can find one of the youngest globular clusters in the galaxy. The mythological picture of Orion is usually depicted with a sword or a dagger hanging from his belt. There's the belt stars, there's the dagger, and these stars correspond to the dagger. You want to look for Orion the belt stars, and then look for Orion's sword or dagger. And if you look with your binoculars up there at the sword, you will see that the middle star is not quite star-like. It's fuzzy. In fact, you can even see this with the eye. If you have good vision, you can tell that there's something a little funny about this middle star. That's something that astronomers have called for years the Orion Nebula. So it's not really a star at all. In fact, it is in some ways a star because there are actually lots of stars right up there that you can find with the with your binoculars or a small telescope. What we have here is another open cluster, but this one is just in the process of forming. You can actually catch this open cluster in the process of forming. Let's go back to another picture for just a moment. Here's a photograph of the Orion Nebula and a few of the stars that you can see sprinkled around in here. Now, it won't look like this to the eye, even in a telescope. This is a photograph where you see lots of detail. But deep down in here, with a small telescope, you can see 4 stars. Here they are, these 4 stars, which make a shape which from high school geometry you may have learned to call a trapezoid, and therefore these are called the trapezium stars, these 4 stars here. These are some remarkable and rare stars. This star, Orion Theta Orionis C, is an O-type star. It's one of the hottest, most massive stars in the galaxy. These O-type stars age very rapidly. They burn up their fuel in just a few millions of years, and then they explode as powerful supernovas. So that star and its companions here have formed out of this nebular material. Now, the material itself blocks our view from very deep into this nebula, but in the infrared, astronomers can find hundreds of stars in here, many of them still in the process of forming deep in the Orion Nebula. If we go back to Stellarium now, Stellarium will attempt to show us a little bit of the structure in the Orion Nebula as well. And you can find the trapezium stars right about in here. We're looking here at stars. This is about as young as they can get for us to still be able to see them. That those O-type stars, and there are B-type stars up there, some of the youngest, hottest stars in the galaxy, these stars are tremendously bright. Remember that the Pleiades is about 400 light years away. The Orion Nebula is like something like 1,350 to 1,400 light years away, 1,000 light years farther away than the Pleiades, and yet we can make out these stars almost by eye, certainly with your binoculars, an excellent binocular object. So when we look up there into the winter sky on these nights, in a way, we're seeing an astrophysics lesson. We're seeing a lesson in stellar astrophysics right up there, from an open cluster in the process of formation right here to a youthful but not brand new open cluster in the Pleiades. There are no O-type stars left up there in the Pleiades. They exploded as supernovas long ago. And then in the case of the Hyades, even fewer bright stars. The B stars that we're seeing here, the hot massive B-type stars, they're gone now from the Hyades. And so we're seeing only a population of much dimmer stars, a population much closer to us, that's why it's larger, and we can still make out those stars, but a much older open cluster than the Pleiades, and certainly than the Orion Nebula. So, you want to keep watching over here, watching Orion. That's easy to do because everybody knows Orion, and it's such a great part of the sky to look at. But in the next 10 million years or so, there ought to be some nice supernovas exploding over here, which will be a great sight if we could catch one. Well, so that's enough on the winter sky for tonight. Thanks for joining me, and as always, keep your eyes on the skies.